In this class, we're going to talk about friction. We're going to look at what is meant by friction, types of friction, laws of friction, general equation of friction, advantage, disadvantage, reduction of friction. Also, we're going to talk about viscosity and laws of viscosity, as well as some pretty work example as touching this concept, friction. The big question is, what is meant by friction? When we talk about friction, friction refers to a force that opposes the motion of two objects sliding over each other. Take note of the important keyword in that definition. Friction is a force. Number one, friction is a force. And this kind of force opposes the motion. Now listen. Oppose the motion of an object. That is, it resists the movement between objects that is in contact with each other. Do you understand? Friction is a force. Are you getting it? And it is not just any kind of force. It is a force that acts against the motion of an object. Are you getting it? So take note of this. Force and opposition. Okay? So having understand what is meant by friction, let us look at the types of friction that we have. There are basically two types of friction. And the first is static friction, and the second is kinetic friction. Let's talk about static friction. Static friction, from the word static, static simply means something is at stationary. Are you getting it? That is, that thing is not moving. And now you combine the word static and friction. Since we know that friction is a force, static friction is a force that is acting on an object that is at stationary. Are you getting it? It is a force that keeps an object at a point. Now, let's say you have a table. Listen. Let's say you have a table here. Then you have a box placed on this table, okay? Let me increase the length of the table. Let's say you have this table and you have a box placed on this table. Now, listen. This box is not moving. So we can say that the kind of frictional force that is acting on this box is what? A static frictional force, right? Now listen to me. If you want to put this box in motion, you have to apply the force, right? Yes. You have to apply a force. Let me call this one applied force. Applied force. It's simple. Just pay attention. I'm going to simplify it to your understanding, okay? Now, when you apply a force, do you know that the frictional force acting on this box also increases? Listen. This box is not moving before. Now, we want to get this box to move. In an attempt to do that, we have to apply the force, right? When you apply a force, the frictional force that is acting on this box also increases. Now, there is another concept known as limiting frictional force. Just pay attention. Limiting frictional force. When you apply force in an attempt to get this box to move, the frictional force acting on this box also increases. Now, it will get to a certain point, it will get to a certain limit called limiting frictional force. Now, when it gets to this limit, until the force that you applied exceeds this limit, the box will not move. Are you getting it? So, when we talk about limiting frictional force, we are talking about a force that is between two surfaces of an object that is in contact. Are you getting it? It's just the maximum force that exists between two surfaces of an object that is in contact. Now listen, this box is in contact with this table at this point. Are you getting it? The limiting frictional force is acting between the surface of the box that touches the table. Are you getting it? And until the applied force exceeds the limiting force, the box will not move. Are you getting it? Now, when the applied force exceeds the limiting force, the ball begins to move. Let me call this friction, because now it will act in the direction opposite to the movement of the box. Are you getting it? So now, when this box begins to move, friction is still acting on it, but the kind of friction that is now acting on the box is called kinetic friction. Do you understand it now? So when you apply the force and the force that you applied exceeds the limiting force, the box begins to move. And now static frictional force changes to kinetic frictional force. Do you understand it now? So when this box begins to move, the kind of friction that is acting on the box now is no longer static. Are you getting it? It is now kinetic frictional force. Please pay attention. Let us have a diagram here. Friction. We have friction. We have the first type here, static. Static. And then we have the second type, kinetic. Kinetic friction. With this arrow here. Kinetic friction. Now, we are here. We are done with this. We are done with this. Now we are here. Kinetic friction is also another type of friction that is acting on the movement, on the motion of an object between two surfaces. Are you getting it? This kind of friction doesn't act on stationary object. It is the object that is already in motion that this kind of friction is acting upon. Are you getting it? Now listen. When an object is in motion, let's say, just like the box, when you apply the force and the box begins to move in this direction, there is an opposing force acting against the motion of this box. It is called kinetic friction. Are you getting it? Kinetic friction. And now listen to me. That is why you will discover that if you kick a ball, no matter the force that you apply, it will go to a certain point where the ball will stop. Do you know why? It is because of this. It is because of this concept, kinetic friction. You will, unless if you want to keep the ball to move, that means an external force, a continuous external force needs to be applied. Are you getting it? So that means if you push this box across this table, if you want to keep it moving, that means you have to continuously apply force. Are you getting what I'm trying to say? So that is the concept, static and kinetic friction. Now, kinetic friction is divided into two. We have the sliding friction. Just pay attention, it's simple. We have the sliding friction, sliding kinetic friction, and we also have the rolling kinetic friction. Rolling kinetic friction. Okay. Sliding kinetic friction, and we have the rolling kinetic friction. Now listen to me. See, the sliding kinetic friction is a kind of frictional force that exists between two flat surfaces. For example, look at this. I don't know where to put this marker. Now look at my hand. You can see that. Let's assume that these are this hand is flat. Also this one as well. You put them together. This kind of friction is called kinetic. When my hands slide over each other, when it slide over one another, the kind of friction that we're talking about here is called sliding kinetic friction. Now, the second one is a rolling kinetic friction. I just divided into two. We have sliding, we have rolling. A typical example of rolling is this. Let's say you have a ball. If you kick this ball, you apply a force, right? The ball begins to roll. Are you getting it? This one is called rolling kinetic frictional force. Do you understand? So do not forget that. Friction is a force. It is not just any type of force. It is a force that opposes the motion of an object that is in contact. Are you getting it? And we have two types, static and kinetic. Kinetic is divided into two, which are sliding and rolling, okay? Now, having understand what is meant by kinetic friction and the types of kinetic friction that we have, I want to ask you a question. Between two types of kinetic friction, which one is stronger and which one is weaker? Is it sliding friction or is it rolling friction? The one that is stronger is sliding friction. Do you know why? It is easier for a ball to roll. Are you getting it? It is easier for a ball to roll over a surface compared to a book that you want to slide over a surface. Are you getting what I'm trying to say? So the sliding friction is much more stronger than the rolling friction. Are you getting it? The sliding kinetic friction is stronger than the rolling kinetic friction. Please take note of that. Also, let's go back to where we start. Static and kinetic friction. Between these two types of friction, which one is stronger and which one is weaker? Static friction is stronger than kinetic friction. Do you know why? It is easier to keep an object that is already in motion in motion. Do you know why? All you have to do is just apply a little force. For example, if you kick a ball, the ball is already rolling, so you just have to apply some little force to keep the ball rolling. Now, but Static friction. First, you have to bring the object, the force acting on the object, you have to make them imbalance. That is only when the object can slide. For example, this box. So you can see that it is easier, it is much more easier to keep an object that is already in motion to be in motion compared to when you want to put an object that is stationary, when you want to put in the motion compared to this. Just like what we have here. Do you understand? So that's it. Now, having understand what is meant by friction, the types of friction, and the meaning of limiting frictional force, let's talk about an important concept known as the general equation. The general equation of friction is this. Frictional force is the product of coefficient of friction and normal force. F is equals to frictional force. Frictional force. Please pay attention. This is the coefficient. I'm going to explain, just pay attention, okay? Coefficient of friction. And N is the normal force. Normal force. Okay. Now, let me redraw the table and the box. Let's say we have a box here. Then we have this table. Just don't mind my diagram. Let's say we have a box, and we have the table. Now, you know what is meant by frictional force, right? Yes. Now, what of coefficient of friction? Please pay attention. Coefficient of friction tells you how much a surface resists the motion of an object. How much a surface resists the movement of an object. That is what coefficient of friction tells you. For example, do you know, let's say you have a ball. Let's say you have a ball and you kick this ball across these surfaces. Then you have another ball. Then you kick this ball. Let's say we have a rough surface. Now the question is, if the force that you apply to both balls are the same, which of these balls will come to rest first? You can see that this ball will come to rest first. Do you know why? Because the surface here is smooth. Are you getting it? But this surface is not smooth. Is that not it? So this is a rough surface and this is what? A smooth surface. Now, what coefficient of friction tells you is that it tells you how much more the surface resists the motion of the object. Are you getting it? It just tells you how rough the surface is. Do you understand? Now, what of normal force? Normal force is the force that a surface exerts on an object which is perpendicular to the surface. For example, look at this box. This box is placed on this table, right? Yes. The kind of force that this box exerts on this table is called weight force. What do I say? Yes, weight force. Weight force. Now, this table, okay, now listen to me. Let's assume that this box is not moving. Do you understand? Now, for an object that is at stationary point, for an object that is not moving, the force acting on the object is balanced. Are you getting it? That means if this box is not moving, something makes it not move. And that thing is that this table also exerts another force that is equal to the weight force that this box exerts on the table. Are you getting it? That force is called normal force. The force that the table exerts on the box is called normal force. Do you understand? That's what I want you to take note. Now, to make this box to move, as we talk in the kinetic frictional force, as we discussed earlier, you have to apply another force to make the force acting on this box to be imbalanced. Are you getting it? So that is only when the object will continue to move. Now listen to me. Let's go back to this equation. We know that frictional force is the product of the coefficient of friction and the normal force. If you want to get the normal force, what are you going to do? Normal force N will be equals to the frictional force divided by what? The coefficient of friction. And also, if you want to get the coefficient of friction, what are you going to do? The coefficient of friction will be equals to the frictional force divided by the normal force. Do you understand it now? Please take note of this equation, okay? Now, having understand what is meant by the general equation of motion and the parameter that we have here, let us talk about the laws of friction, okay? The first laws of friction that we're going to talk about is the frictional force between two surfaces opposes their relative motion. When we talk about relative motion, the motion of an object from a viewpoint is called relative motion. We know that friction is a kind of force that opposes the motion of an object, right? So when we talk about frictional force, the first law, frictional force, the frictional force between two surfaces opposes their relative motion. Okay, listen to me. Let's use this as an example. You know, this box is placed on this table, right? If you want to put this box in motion, a force will tend to stop the box. That force is called frictional force. Are you getting it? The direction in which the motion is moving with respect to a viewpoint is called the relative motion. Do you understand? The relative motion. Do you understand? So that is according to the first law. The second law, I may not write the second law, just write it in your notes. The second law of friction states that the frictional force is independent of the area of surface in contact, while the normal reaction is constant. I'm going to explain, just pay attention. The frictional force is independent of the area of surface in contact. That is, the frictional force doesn't depend on the surface area in contact. Pay attention. Let's say you want to slide a block. You want to slide a block. This is a block. You want to slide a block across this ground. Now listen to me. Do you know this block is standing upright, right? Let's say you have a friend that also want to slide the same block of the same weight across this surface, and your friend placed the block like this. Are you getting it? Now, listen to me. When you apply force, the frictional force that you feel from friction is independent of the area, the part of the block that touches the ground. Are you getting it? That is the second law. The frictional force is independent of the surface area of the object that is in contact with the ground. For example, this box, the part of the box that is in contact with the ground is this. Now, when you push this box, the frictional force that you observe, the frictional force that want to stop the box doesn't depend on the area, the part of the box that touches the ground. Are you getting it? That is the summary of the second law. That is why we discover that the mathematical representation of frictional force is the product of coefficient of friction and the normal reaction. The frictional force will not change much. No matter, in fact, if you place okay, look at this. Your friend placed his box like this. Do you know that this box, this is small area of contact, small area of contact, while this is large area of contact. If the normal reaction, by the way, normal reaction is caused by the normal force that a surface exerts on an object that is perpendicular to the surface. Are you getting it? So don't get confused. Now back to this. Do you know, no matter, it doesn't depend. Though this surface area, the area of the box that is in contact with the ground is large here, it doesn't depend, the frictional force doesn't depend on it. If the normal reaction between the block and the ground is constant, are you getting it? That is the summary of the second law. The frictional force will still be the same frictional force. So do not forget, the first law states that the frictional force between two surfaces opposes their relative motion. No, I told you when we started the class that friction is a force that opposes the motion of two surfaces sliding over each other. Now for the second law, the frictional force is independent of the surface area in contact, provided that the normal reaction is constant. Do you understand? That is, the frictional force doesn't change much. No matter how large or smaller the areas of the object that touches the surface, the frictional force doesn't change much. Okay, according to the third law, the limiting frictional force is directly proportional to the normal reaction in the case of static friction, while the frictional force is directly proportional to the normal reaction in the case of kinetic friction, and it is independent of the velocity of the surface. Please pay attention. This third law is break into two parts. Are you getting it? And I told you what is meant by limiting frictional force. Limiting frictional force is the force that you must overcome if you want to put an object that is at rest. If you want to put the object in motion, that force needs to be overcome. And that means limiting frictional force is only with respect to static friction. Are you getting it? Because in kinetic friction, the object is already in motion. So there is nothing like limiting frictional force. Is that not it? So according to this third law, the limiting frictional force is directly proportional to the normal reaction in the case of static friction. Pay attention. Let's say you want to slide this book. Are you getting it? This book is placed on the table and you want to slide it. Now, according to the first part of the law, talking about static friction, the limiting frictional force, the force that needs to be overcome before you can put this box in motion, is directly proportional to the force that the table exerts on the box. Do you understand? That is why this equation, you see, when you understand this equation, all this law, this law is just the summary of the equation. Are you getting it? That is why we often see that static is proportional to the normal reaction. Are you getting it? And if you want to change it, if you want to change this variation sign, I'm very sure you are well grounded in variation in mathematics. According to this law, the limiting frictional force is directly proportional to the normal reaction in the case of static friction, right? Now, if you want to change this variation sign to an equals to sign, what will happen? You're going to have static friction is equals to coefficient of friction multiplied by the normal reaction. Is that not it? Now, come back to the example. That means, oh God, pay attention. This is getting interesting. Let me quickly erase this part. That means, let's say you have a piece of block and the weight of the block is 20 Newton. Then you have another piece of block and the weight of the block, if this weight is double, what will happen? This will be what? It will be 40 Newton. Now, if the weight of this block is double, it will be what? 80 Newton. 80 Newton. Now, in the case of static friction, static simply means the object is not moving, right? So we assume that this block is not moving. Now, according to this law, the limiting frictional force, the force that needs to be overcome before this block can move, is directly proportional to the normal reaction. I told you that normal reaction is created by the normal force, and the normal force is the force that the table exerts on the box. Are you getting it? Now, for an object that is stationary, this force, the force that the block exerts on the table will be equal to the force that the table exerts on the box. Are you getting it? Because if an object will be stationary, the force must be balanced. Is that not it? Now, back to this. Since this force is doubled here, the normal reaction will also be what? Will be double. That is why when I start the definition of, when I want to help you to understand static friction, I told you that if you increase the force that you applied to put the object in motion, the normal force also increases. Are you getting it? And until it exceeds the limiting frictional force, the object will never be in motion. Do you understand? So that is all about the first part. The first part says the limiting frictional force is directly proportional to the normal reaction or the normal force. So that means if you increase the weight of the box, the normal reaction, the normal force also doubled. If this is 40 Newton, the normal force also is what? 40 Newton. If this is 80 Newton, the normal force is also what? 80 Newton. Do you understand it now? That is the case of static friction. That is the first part of that law. Now, to the second part. Oh, let me erase. Okay, let us erase this. Let's erase this. Now, the second part of that law is that the frictional force is directly proportional to the normal reaction, and it is independent of the velocity of the surface. Okay? The frictional force is directly proportional to the normal reaction. This one is in kinetic friction. Kinetic friction. Do not forget that we only have limiting frictional force in static friction, okay? Now, this one is kinetic friction. The frictional force is directly proportional to the normal reaction, and the frictional force is independent of the velocity of the surface. Do you know the meaning? That means in kinetic friction, the frictional force doesn't depend on the velocity of the surface. The only thing that we are concerned is the normal reaction. How hard the object pressed to the surface is called the normal reaction. Are you getting it? How hard the object, for example, look at this. Let me draw another table. you will notice that I'm using table. That is what I just want to help you to understand this. Now, we assume that this object is moving. Are you getting it? Now, the normal reaction is how hard the object is pressed towards the table. Now, if you want to change this variation sign to equal to sign, what will happen? You're going to have coefficient of friction multiplied by what? The normal force. In this equation, you can see that you cannot have any parameters that is related to the velocity. That is why we said the friction is independent of the velocity of the surface. It doesn't matter. The velocity doesn't affect the movement, the frictional force. Are you getting it? No matter how fast the object is being pushed, no matter how fast no matter the speed of the object, all we are concerned about is the normal reaction that comes as a result of the object being pressed towards the surface. Are you getting it? So that is all about the laws of friction. Number one, frictional force between two surfaces opposes their relative motion. Number two, frictional force is independent of the surface area of contact when the normal reaction is constant. Number three, that one is divided into two. The limiting frictional force is directly proportional to the normal reaction in the case of static friction, while in the case of kinetic friction, the limiting frictional force is, the frictional force, is directly proportional to the normal reaction, and it is independent of the velocity of the surface.
To watch the complete class, kindly click on the link in the description of this video or the comment section, okay? See you in the next class.
Okay, let us talk about viscosity. Viscosity refers to the internal friction that exists within a fluid. Do you understand? The name given to the friction exerted by a liquid is called viscosity. Do you understand? Now, do you know why solid friction exists between two solid objects which are in contact? Viscosity occurs in liquid. Do you understand? It occurs in fluid as they move past each other. So it can be referred to as thickness or thickness of a fluid. Do you understand? Okay. Now, having understand what is meant by viscosity, let us talk about the law. I gave you the law of solid friction. Are you getting it? Now, we want to look at the law guiding this concept, viscosity. According to this law, the frictional force acting on a layer of a fluid moving in a uniform flow is directly proportional to the areas of the layer and the velocity wherein it is situated. Just pay attention. I'm going to explain, okay? It's simple. It's simple. Just pay attention. This law states that the frictional force acting on the layer of a fluid, the frictional force acting on the layer of a fluid moving in a uniform flow is directly proportional to the area of the layer and the velocity gradient wherewith it is situated. Pay attention, see. In solid friction, before I write, in solid friction, we said the frictional force is independent of the area. Do you know? And also, the solid friction is independent. The frictional force is independent of the velocity gradient. Is that not it? But that is not so in viscosity. In viscosity, the frictional force depends on the area. It also depends on the velocity gradient. Okay, now listen. According to this law, I can represent it mathematically as the frictional force is directly proportional, number one, to the area. So let me represent the area as A, to the area of the layer, and also is directly proportional to the velocity gradient. Let me call it dv delta v over delta y. Now listen to me. In mathematics, if you want to change this variation sign to an equals to sign, what will happen? That means you have to introduce a proportionality constant. Is that not it? That proportionality constant in this concept is called the coefficient of friction. Are you getting it? So I'm going to have F is equals to the coefficient of friction multiplied by the area multiplied by the velocity gradient. Okay? Where this is the coefficient of friction. Coefficient of friction. Just listen, okay? It's simple. A is the area of the layer. And then we have the last parameters here, which is the gradient, velocity gradient. That is the so please, we are still going to make use of this law. So I want you to master it, okay? Viscosity is for liquid. Are you getting it? And for solid friction, that is for solid. Are you getting it? So viscosity is for liquid. Now, if you are asked this question in exam, differentiate between viscosity and solid friction. What are you going to do? There are two things that there are two silent things that differentiate both law. The first is number one, the area. You know, according to this law, the area, the frictional force is directly proportional to the area, but in solid friction, the frictional force is independent. Are you getting it? That means it doesn't depend on the area. Now, the second thing is that the frictional force here depends on the velocity gradient. Why in solid friction it is not so? Do you understand? So kindly pay attention to that. Okay, having understand what is meant by viscosity and the laws of viscosity, let us talk about reduction, advantage, and disadvantage of friction. Okay, please, I want you to pay attention. You can be asked this in your exam. You didn't have to cram. Just understand this and put it in your own words. Now, reduction. Let's look at reduction of friction. Reduction of friction. Now, there are various methods. There are various ways in which friction can be reduced. And the first that we're going to talk about is use of lubricants. Okay? Use of lubricants. Use of lubricants. This method is the most common method that is used in reducing friction. What are lubricants? Example, we have oil, we have grease, we have graphite powder, and so on. So, in an attempt to, this is how the method works. You know, friction, when two surfaces are in contact and one slide or move over one move over another, frictional force tends to resist the motion. Now, in an attempt to prevent the two surfaces to be in contact, you add lubricant in between the surface, maybe oil. Do you understand? So now listen to me. Let's say, look at my hand. Even though I'm able to slide my right hand across my left palm, sorry, my right palm across my left palm. Now assume that I put oil. You will see that it will be easier. Are you getting it? That is the work of lubricant. It is help to reduce the friction by not allowing the two surfaces to be in contact. How? You put the lubricant in between the two surfaces. Do you understand? Okay, another method is the use of ball bearing. Ball bearing. ball bearing. Now, I gave you two types of kinetic frictional force, right? One is sliding kinetic frictional force, and the other is rolling kinetic frictional force. Now, listen, this one that you see here, do you know why the tire of your motor car is made round? It is to reduce friction. Imagine if the tire of your motor car is made in another shape, maybe square or rectangle. You can see that the engine will be much stressed compared to when it is round. So, okay, let's take for instance, look at the ball that is played on the pitch. It is made round because rolling friction easily move across. Rolling friction is less. Let me just put it like that. Rolling friction is less compared to sliding friction. That is why you will often see the tire of a motor car is made like this and not like this, or not like this, or not rectangular shape. Okay, and also if you check ball is spherical in shape, so it is easier for both to move across the surface compared to if it is made of another shape. Do you get it? Another method of reducing friction is by polishing the surface. Are you getting it? Please pay attention. Polishing the surface. Now, this is how the method works. When you polish a surface, you make the surface smooth. Are you getting it? You reduce the coefficient of friction. Now, it is important to note that this method needs to be combined with other method, because when the surface becomes so smooth, the frictional force can increase because the objects stick to the surface. Are you getting it? So you can combine this method by with lubricant method by applying oil or grease. So this method also is part of the method of reducing friction. The fourth method of friction reduction is streamlining. You can read more on that. This method is mostly applicable to friction in liquid. Do you understand? Okay, so we've talked about lubricant, ball bearing, polishing the surface. We've talked about streamlining.
Okay, let us talk about the advantages of friction that we have. The first advantages of friction is seen in walking and locomotion. Walking, walking, and locomotion. Please pay attention. You see, friction is important in walking and locomotion. How? Without friction, walking will have been you trying to move over a very perfectly smooth surface or an ice. But because of friction, when you take a step, your foot is being forced to push against the ground. And because of that, you then slide. This is how it works. Friction creates a reaction force. Are you getting it? And this reaction force keeps you on your feet. So that is one of the importance. It's important in walking. As you are walking, ordinarily as you are walking, if the surface area is perfectly smooth, imagine trying to run over a rice. How will you feel? We discover that if you want to stop immediately, you won't be able to stop. Do you know the reason why? Because the surface of the ice is frictionless. Are you getting it? So that is it. Friction is important in walking and locomotion. The second that we're going to talk about is in braking and safety. Friction is also important in braking and safety. Now, this is very important. Do you know that the major mechanisms that help us to stop a moving vehicle, that helps a driver to stop a moving vehicle, is because of friction? I'm going to explain. Just pay attention. You see, when you apply brake to a moving vehicle or bicycle, do you know what happened? The brake pad is being pressed against the wheel. Are you getting it? And when that happens, a very powerful kinetic frictional energy is generated, thereby turning the kinetic energy of the motion into its energy. And then the motion of the vehicle is brought into safety. Are you getting it? So that's how it works. You can see the importance of friction. So that is the beauty of the concept that we're looking at. Friction is very, very important in life. And the third advantage is mechanical fastening. Mechanical fastening.
Fast. Now, you see, I'm going to explain. You see, all this, you don't have to cram it. Just understand the explanation and you will remember everything in your exam. Now, this is how it works. Do you know most of the things that we see around us are held by friction? Take, for instance, let's say you drive a nails into the wood. Are you getting it? Do you know what happened? Do you know why it stick? It stick because the fibers created by the fibers of the wood exert a frictional force on the nails. Are you getting it? That is why you will see that it is easy. For example, this whiteboard marker is held on this plank by nails. You understand? I use nails. I drive the nails to through the whiteboard marker. That's why we can see it can stand here. And the reason why it can stand and the reason why the nail can hold it is because of the frictional force. Are you getting it? So you can see the importance. First, working and locomotion. Second, braking and safety. And the third, mechanical fastening. The fourth advantage of friction is seen in writing and gripping. Now, I'm going to do this one is practical. You see, I'm using this marker to write on the board. Do you know why you can see what I'm writing? The simple reason is simply because of the frictional force that exists between the particles of the ink and the board. Are you getting it? That is why you can see what I'm writing. And the reason why I can hold this marker is because of frictional force also. The frictional force that exists between my palm and the curved surface area of the marker. Are you getting it? So you can see that friction is important in our daily life. Another important is heat generation. Heat generation. Now let's go back to our kitchen. I'm very sure you will have seen matches, right? Now, if you want to make use of matches, you have to take the stick and drag it up on a particular surface area. Do you know why it gets lightning immediately it passes through that surface area? It is simply because when you slide it over that surface area, heat is generated and to ignite the spark, and thereby you have lightning, which you can use. And another thing is this: do you know in the olden days, most of our forefathers, what they do is this: they take two stone, they drag it, I mean, they slide it over one another. They're going to see a light. That light is created by heat. Do you understand? Another thing, another phenomenon is this: try rubbing your palm, your two palm, try rubbing it or sliding it over each other for a long period of time. You are going to discover that you're going to have heat. Are you getting it? So you can see friction is also important in its generation. Okay, so master these five: working and locomotion, braking and safety, mechanical fastening, writing and gripping, and its generation. Then you can put explanation, your own explanation as touching the way you perceive each of the point. Put it at the front. You are going to have your full mark. Okay. Having talked about the various advantages of friction, now let us look at the disadvantage. Do you know that even though friction has disadvantages, it can also, oh, sorry. Now, having talked about the advantages of friction, let us look at the disadvantages, okay? And the first is wear and tear. Disadvantages, disadvantages of friction. The first is wear and tear. Friction causes wear and tear. The second is reduction in motion. And the third is heat generation. Heat generation. The fourth is noise pollution. The noise pollution. You can have as many disadvantages as you want. Are you getting it? But I'm going to give you all this for now. I'm just going to brief the explanation. You can read more on it. Now, do you know friction causes wear and tears? When you have an object sliding over a surface continuously, you will discover that something happened. What happened? It is generated because friction converts kinetic energy. It converts kinetic energy to thermal energy. Now, when it is generated, you will discover that the surface begin to lose. Are you getting it? The particles of the surface begin to lose. That is it. Wears and tears in place. And the second point here, we have reduction in motion. Friction reduces the motion of an object. From the definition, friction is a force, and it's not just any kind of force. It is a force that opposes the motion of an object. Are you getting it? That is why it is special. Okay. So, and the third point we've explained, you can read more on noise pollution. Okay. Now, let's look at this important concept on friction. Friction on inclined plane. Inclined plane look like this. Please pay attention. Friction of an object on inclined plane. This concept, most questions do come out from it. So I want you to pay attention. Inclined plane look like this. Okay. It can also look like this. You can also have it. You can have it like this. Like this. Yes. Okay. Now, do you know? Let's say you have an object placed here. This is how inclined plane look like. Do you know that this angle is inclined to the horizontal? I'm going to explain. Just pay attention. You see, the reason why I'm taking this one by one is because at the end of this class, we're going to have some multiple choice question that will test you across everything that we've learned in the class. Okay, so pay attention to this. Friction on inclined plane. Friction on inclined plane. That is what we are discussing. Now, look here. This is how inclined plane look like. Let's say we have a box placed here, okay? And we have this angle being inclined to the horizontal, of course. This is horizontal. Now, do you know that, let's say this box is not moving. Hello? Let's say the box is not moving. What happened? The box is not moving because, number one, the force on the box is balanced. Are you getting it? Do you understand? Now, this angle is called angle of repose. Angle of repose. I'm going to explain. Just pay attention. Angle of repose. Do you know why? Angle of repose is the maximum angle that you must have for an object on inclined plane not to move. Are you getting it? Not to undergo motion. When you have an object placed on inclined plane and the object is not undergoing any motion, is not moving, is stationary, the angle here is called the angle of repose. Do you understand? It is the maximum angle that you must have for an object placed on this plane not to move. Are you getting it? Now, do you know if the object is not moving? Pay attention. It is getting serious now. Pay attention. I'm going to redraw this so that you can understand. Let's say I'm still going to draw it the same way, but I want to explain something very important here because most students find it hard to comprehend something like this. Now, if this box is not moving, do you know the box is not moving because the force around the box is balanced? Now, if the force around the box is balanced, that means a force come here and press the box against this plane, right? And we know that the force is called what? Weight force. Are you getting it? And weight force is what? Mass times acceleration due to gravity. Is that not it? Now, the force that pressed this box, are you getting it? The vertical force that comes from this can be represented as mg cos theta. Okay? Let's say this box is moving. This box that you see here, let's assume that it is moving. Do you know that there are two forces that is acting on it? Number one, a downward force. Are you getting it? Number two, another force that is letting the box to move like this. Are you getting it? The downward force pressed the box against this plane. It pressed the box against this surface. Are you getting it? That downward force is called what? Weight force, right? Now, if the box is stationary, that means another force has to be exerted on the box called normal force. Is that not it? Now, I'm telling you that the force here can be represented as mg cos theta. If you want to explain the total force acting on this box, we can resolve the force into component. Number one, horizontal component and vertical component, and that is what I'm trying to explain. Okay. Now, if this box is moving, two force, we can resolve the force of the box into components. Number one, horizontal component, right? and number 2, vertical component. Now, for this one, I'm going to have another force that tends to oppose the motion of the box along this side. That is what? Frictional force. Now, when the box is moving like this, the force can be represented as mg sine theta, horizontal component. Horizontal component. Mg sine theta, and we have another component known as the vertical component. That is mg cos theta. I just hope you understand what I'm doing. It's simple. Honestly, it's simple. All you have to do is just pay attention. Let's say the box is sliding across the surface. Do you know there are two main forces that is acting on the box? The box will be moving like this, and also there is another force that tends to pull the box downward. Are you getting it? Now we've resolved the forces acting on this box into two components. Now, if you don't want to call this component horizontal component, you can call it parallel component. Are you getting it? Parallel component. In some textbooks, you are going to find as parallel. Don't get confused. It's still distinct, okay? And if you don't want to call this vertical component, you can call this perpendicular. Are you getting it? Perpendicular. It is perpendicular because it is acting at 90 degree. Perpendicular, okay? Let me erase this. See, I will help you to understand what I'm talking about. It is important because you might encounter such question in your exam. So please pay attention. So the parallel component or the horizontal component, the parallel component, we have mg sine theta, and the maybe horizontal vertical component or perpendicular component, anyone you want it. I put the two so that you won't get confused. If you open some textbook, you're going to have it like this: perpendicular component. We have mg cos theta. Now listen, do you know I assume that if the box is moving, what will happen? If the box is moving, if it moves in this direction, do you know that there is a force that tends to oppose the motion in this direction? That force is what? Frictional force, right? Yes. Frictional force. Frictional force tends to oppose the motion of the box when it tends to move towards this direction. Now, if the box is pressed, are you getting it? There is another force that acts opposite to the weight force. I call it what? Normal force. Normal force. If you don't want to call it normal force, you can call it normal reaction. Normal reaction. Do not forget. Okay? Now, come back. Do you know that if this box is at stationary, that is, if the box is not moving, do you know that when this box tends to move like this, what will happen? The frictional force will tend to oppose the motion of the box. Are you getting it? And from our basic, from the general equation that I gave you earlier, frictional force is the product of the coefficient of friction and what? And normal reaction. Are you getting it? Now, the frictional force, if the box is at stationary, that means the frictional force is equal to what? Mg sine theta. Because now we resolve the horizontal component of the force as what? Mg sine theta, and the vertical component as what? Mg cos theta. Now, when the box tends to move like this and it is unable to move, it is unable to move because frictional force acts against the direction of the motion. Is that not it? Now, that frictional force must be equal to the force that tries to push the board towards this direction. The force that tries to push this box towards this direction, the frictional force must be equal if the box will not move. Are you getting it? So that means I can replace F, which is the frictional force, as what? Mg sine theta. Are you getting it? This will be equals to the product of coefficient of friction and now normal reaction also can be replaced at mg cos theta. Do you know why? If this box will remain as stationary, that means the force that is exerted by the box on this surface must be equals to the force that the surface will exert on the box, which is the normal force. Are you getting it? And I told you, normal force can also be represented as what? Normal reaction. So I can say that N is equals to what? Mg cos theta. Do you understand it? Okay, let us get the coefficient of friction. What am I going to do? I'm going to divide both by what? Mg cos theta. And this over what? Mg cos theta. Okay. Let me erase this. I just have to be fast. So if you don't understand, just try to reverse the video and listen to the explanation. Okay, listen to it again. So that means coefficient of friction will be mg sine theta all over mg cos theta. So mg will cancel mg. I'm going to have sine theta all over cos theta. Now, do you know in trigonometry, sine theta over cos theta is what? Tan theta. Basic trigonometry. So that means coefficient of friction will be equals to tan theta. Do you understand it? So please note this formula. Take note of this formula, okay? Because it will be important as we delve into calculation as touching this concept. In an attempt to test our understanding as touching what we've been discussing on this topic, I've drafted out some multiple choice questions which you may encounter in your exam. So I want to pay attention even as we solve. Now, I want to do something. When I call the question, try to choose the answer by yourself. And when you're done choosing the answer, play the video to listen to the explanation that I made as touching the answer that you choose, okay? If you get it right, kudos to you. If you get it wrong, you give yourself a chance to learn. Are you getting it? Okay, let's look at the first question here. When an object is at rest, the frictional force that must be overcome to start motion is called A. Kinetic friction, B. Limiting friction, C. Rolling friction, D. Dynamic friction. Please pay attention to the options. When an object is at rest, what kind of frictional force is acting on the object? Static frictional force, right? Yes. Now, to bring the object to motion, you have to apply a force. And until that force is greater than the force that keeps the object at rest, the object will not be in motion. The force that must be overcome is called limiting friction. Are you getting it? So the correct option to that question is option B, limiting friction. Option B is correct for question 1. Option B is correct, limiting friction. Okay? For question 2, which of the following is the correct unit for the coefficient of friction? Okay? You know, coefficient of friction is represented by this. This is it, coefficient of friction. Now, we are asked for the unit. What is the unit of coefficient of friction? Do you know coefficient of friction is a constant? Are you getting it? And constant don't have unit. Do you understand? So, the correct option, oh, I've not given you the option. The first option here is Newton, B, Pascal, C, joules, D, it has no unit. The correct option is option D. Coefficient of friction does not have any unit, okay? The third question. If the normal reaction between two surfaces is tripled, the frictional force will A, decrease by half, B, triple, C, remain the same, D, increase ninefold. Okay, to help us to understand this, the answer, let us look at the general equation of friction. Friction is the product of coefficient of friction and normal reaction. Now, in the question, we are told that the normal reaction is tripled. So, I'm going to have friction will be equals to coefficient of friction multiplied by what? 3n, right? Because it is tripled. Now, if it is tripled, the result will be what? F is equals to 3 multiplied by coefficient of friction multiplied by what? The normal reaction. Now, do you know that because frictional force is directly proportional to the normal reaction, that means if an increase in the normal reaction will lead to what? A corresponding increase in the frictional force. Are you getting it? That means if the normal reaction is tripled, the frictional force also will be what? Tripled. So the correct option to that question is option B. Okay. How many how many answers have you gotten? We have answered 3 questions now. How many answers have you gotten? Drop it in the comment section. Okay. Number 4. I'm coming. Number 4. A car tire is designed with threads primarily to A, increase friction on wet roads, B, reduce the weight of the car, C, make the car move faster, D, convert rolling friction to sliding friction. Okay, now what do you mean by threads in a car? That's the first thing that you have to know. What do you mean by threads? You know, when you check the tire of a car, you will discover that there are patterns. Are you getting it? Patterns of lines drawn. Are you getting it? The goal is to um the goal is to increase the friction on a wet road. Are you getting it? You know, wet roads are slippery. I'm just talking with respect to the option that we have here. There are other importance of that rest. Are you getting it? But as touching the option that we have here, the correct option is option A. Why? Because on a wet road, it will be slippery. Are you getting it? If there is no tread on the car, the friction will be less. Are you getting it? And you know that if the friction is to increase friction, the surface area of the tire, you know, the treads acts like something like a grip. Are you getting it? It grip the tire across the roads. Are you getting it? So it increase friction on the wet roads. If you choose option B, you are wrong. It doesn't reduce the weight of the car. If you choose option C, it is closer to the answer, but that's not the correct answer. If you choose option D, convert rolling friction to sliding friction. That is also wrong. Are you getting it? The correct option is option A. Tread channel away water. Are you getting it? So that's it. And the fifth question here is in the derivation for an inclined plane, the component of weight acting parallel to the plane is A. mg cos theta, B. mg tan theta, C. mg sin theta, D. mg. Okay. You know, I just gave you component of inclined plane. I told you the parallel component. I gave you the perpendicular component, that the force acting on a box resting on an inclined plane, the component can be resolved into horizontal and vertical, you know. So now we are asked that in the derivation of an inclined plane, the component of the weight acting parallel, what is the answer? The correct answer is option C, mg sin theta. Do you know why? The force pulling the object down the slope, that is what we known as mg sin theta. This is an inclined plane. Are you getting it? Oh, sorry. Let me change the marker. Now, this is an inclined plane. This is an inclined plane. Let's say we have an object here. This force is called mg sin theta, and that is the force acting horizontal or parallel. So the correct option to this question is option C. Option C is correct, mg sin theta. Let's look at question. Oh, okay. Which option are we? Oh, this will be question 5. Sorry. And this will be question 6. I didn't write the answer for question 4. But don't worry. I hope you can see it on the screen. Now let's look at question 6. The angle of repose is defined as the angle at which an object A moves at constant velocity, B is just about to slide down a slope, stop moving completely, B experiences zero friction. Okay, the correct option is option B. Do you know why? The maximum angle of stability, I define it for you, know. The maximum angle of stability is called angle of repose. Are you getting it? And it happens on inclined plane, you know. The angle here is called angle of repose, provided that this box is not moving. Do you understand? So the correct option to that question is option B. Option B is correct. Okay. Now for question 7, we have mathematically the coefficient of static friction U on an inclined plane is equal to, okay, static friction on an inclined plane. You know, I gave you a formula. I derived a formula for you as touching inclined plane. Coefficient of friction is tan theta. Tan theta. And it is what? mg sin theta, the ratio of the horizontal component, the weight force of the horizontal component, and the force on the vertical component. That is mg cos theta. Their ratio will give you what? Tan theta. Are you getting it? So the correct option to that question is option C. Okay. For question 8, we have which type of friction is generally the smallest? Okay. I love this question. You know, we have different types of friction. We have static and kinetic. Kinetic is further divided into two, which are what? Another, okay, let me take it like this. Another name for the kinetic friction is dynamic friction. Okay, do not forget. So when you hear the word kinetic or you hear the word dynamic, know that they are the same, okay? So now, there are two types, basically two types of friction, which are the static and the kinetic. Kinetic is further divided into two, which are the rolling friction, rolling kinetic friction, and sliding kinetic friction. Now, we are faced with a question here that is testing us on our knowledge on types of friction. What are we asked to choose? Choose the smallest, the one that has friction that is small. We have A, static friction, B, kinetic friction, C, rolling friction, D, limiting friction. The correct option is option C, rolling friction. Rolling. Do you know why? I'm coming. Rolling friction is a type of kinetic friction, and I've already explained all this. So if you missed the class, you can check the link in the description of this video, okay? So do not forget. Rolling friction is the smallest. If you choose sliding, you are wrong. If you choose kinetic, you are also wrong. Okay. Now let's look at number 9. Viscosity is often described as A, external friction of solids, B, the density of liquid, C, the internal friction of a fluid, D, the weight of a fluid. The correct option is option C, number 9. Option C, viscosity is the internal friction. Internal friction. Do not forget, internal friction of a fluid. The name given to the frictional force that a liquid or a fluid exerts is called viscosity. Do you understand? So do not forget that. Now let's look at question 10. According to the law of viscosity, the viscous force is proportional to A, the volume of the fluid, B, the area of the layer and the velocity gradient. Okay. C, the density of the fluid, and D, the depth of the fluid only. The correct option is option B. Do you know why? Do you know I gave you this formula? Viscosity. If you understand the law alone, you are good to go. Number 10, I gave you this formula. F is directly proportional to area, the velocity gradient, which is delta V over delta Y. Are you getting it? And so if you want to change this variation signs to equals to sign, what will happen? You have to introduce a proportionality constant, right? So you're going to have F is equals to coefficient of friction multiplied by the area multiplied by what? The velocity gradient. You can see that here, the frictional force, the viscous force. You see, this force here is called the viscous force in friction in liquid. Are you getting it? So the viscous force is directly proportional to the area and the velocity gradient. That is what makes option. Let me check the option again. Option B. Option B is correct, okay? Option B, okay. Out of question 11. For question 11, we have, how does the viscosity of a liquid change with an increase in temperature? Okay. A, it increases. B, it remains constant. C, it decreases. D, it doubles. The correct option is option C, it decreases. Viscosity of a liquid change when you increase the temperature of a liquid, the viscous force reduce, because when you eat a liquid, it makes it thinner. Are you getting it? It will make it less viscous. For example, let's say, okay, take for instance oil. When you heat oil, we discover that it changes the thickness. And I told you that viscosity is measures the thickness or thickness of a fluid. Are you getting it? So it's less thick when it is being heated. So the correct option to that question is option C. Okay, option C. The viscosity decreases. Okay. Let me erase the board so that we can have more space to pen down our answers. If you have any question, don't hesitate to reach out to me, okay? And if you have anything bothering you as touching this course, don't hesitate to reach out to me as well, okay? Now we stop at question 11. Let's proceed to question 12. We are still going to look at calculation though. You see, yes, we're going to look at calculation. So just now, lubricant like engine oil are used in machine to A, increase the normal reaction, B, increase the heat produced, C, reduce friction by separating surfaces, D, increase the weight of the part. I told you there are different methods of friction, reduction of friction. You have lubricant, ball bearing, and now I told you that lubricant is the most widely used method of reducing friction. How does it work? You apply the maybe oil grease. Lubricant can be in form of oil. It can even be in form of powder. You apply this lubricant between the surface. Are you getting it? So, and in that means the surface will not be in contact directly. Are you getting it? Instead, the lubricant will be in between the surfaces. So the correct option is option C. Reduce friction by separating surfaces. Okay? Option C is correct. Now you can see the reason why you choose an option now. You don't just choose an option haphazardly, okay? You must choose with respect to what you know. You are choosing the option because you know that it is correct and you know that other options are not correct. Let me teach you how to answer multiple choice question. You have to know the reason why your answer is correct, why the option you choose is correct. And that comes by knowing the reason why the other options there are not correct. Okay, for instance, look at this question number 12. In lubricant doesn't increase the normal reaction. If the normal reaction increases, what happens to the friction? The friction also increase. Why? Because frictional force is directly proportional to the normal reaction. So that cannot be the answer. Are you getting it? So you can examine other options. So now let's proceed to number 13 on our list here. Which of the following has the highest viscosity at room temperature? Okay. Number one, okay, A, we have water. B, we have air. C, we have petrol. D, we have honey. The correct option is honey. You see, just measure the thickness itself. Honey is more thicker compared to other one. Petrol is kind of volatile. So the correct option is honey. Number 13D. 13D. That means if you want to answer question on this topic, you have to be well grounded. Are you getting it? And that is why I take time to explain each of the concepts. I start from friction. We look at the type. We look at the laws. We look at general equation. We look at advantage, disadvantage, reduction. We look at viscosity, law of viscosity. And so I take it one by one so as to help you to understand that question that comes under this topic, you can get everything right if you pay attention. Okay. So we stop at question 13. What of 14? A streamlining, a streamlining shape like that of a plane is designed to A, increases the surface area, B, minimize viscous drag, C, make the object heavier, D, eliminate gravity. Correct option is option B. One of the method of friction reduction is changing the shape of an object. Are you getting it? So, and I told you that streamlining is mostly used to reduce friction in fluid. Are you getting it? So, the correct option to this one is option option B, minimize viscous drag. Option B, number 14, option B, minimize viscous drag. Now, what of okay, I don't want to stay much on this. Let's just proceed to the next question. I actually want to ask you another question, but I don't want to bring it up. Now, when you rub your hands together to generate it, you are converting. Aha. Honestly, I like all these practical questions. I like it. Oh, yeah, now rub your hand. As you are even watching me now, try rubbing your hand together so that you can know the answers to the question. When you rub your hands together, now, your palm now, to generate it, you are converting A, chemical energy to mass, B, potential energy to gravity, C, work done against friction to heat into friction. Now, when you rub your hand together, you generate it, right? Work is done, right? Now, when work is done, what kind of work is that? You can see that you are moving against friction because the heat that is present that you perceive is because of the frictional force that exists between your palm. Are you getting it? So the correct option to that question is option C. Option C. In fact, if there is no friction, if work is not done against friction, you won't feel any heat. Are you getting it? Your palm will still be the same, the temperature will still be the same. But when you move something against another thing, you will feel something. Are you getting it? It's just as if you're trying to push an heavy box. And every box requires a lot of energy to push. Are you getting it? So imagine that energy as the heat that your hands generate because you are moving against friction. The work is done against friction. You cannot have any other option that is correct except that option. Okay, for question 16. For gases, unlike liquids, viscosity usually decreases with temperature, B increases with temperature, C remains zero, D depends only on volume. You see, unlike liquid, when you increase the temperature of a gas, the particle tends to collide together. Are you getting it? So that means the frictional force increases. You understand? The viscosity increases. It increases with temperature. So the correct option is option B. Option B is correct. Sorry, I don't know what happened to the marker. Option B is correct. Now for 17, for question 17, the coefficient of viscosity N is measured in, okay, this one I didn't tell you. The correct option is coefficient of friction in fluid is measured in pascals. Are you getting it? So A, we have what? B, pascals. C, meters per second squared. D, kilogram per meter. The correct option is pascals, okay? Number 17, B. Out of question 18. Question 18, we have, okay, this is a calculation course. Calculating question. So let me just put it here. If a block of mass 10 kilogram is on a flat table, let me draw it. On a flat table, we have a box of mass 10 kilogram. 10 kilogram. Okay. The coefficient of friction is equals to 0.2. So coefficient of friction 0.2. What is the limiting friction? And we are given that G, acceleration due to gravity, is what? 10 meter per second squared. Okay, this is the question. A box of mass 10 kilogram is placed on the table and the coefficient of friction is 0.2. We are asked to calculate the limiting frictional force. Now, what is limiting frictional force? The force that you have to overcome in order for this box to be in motion. Is that not it? Yes. Now, do you know when this box is resting on this table, the kind of force that the box exerts on the table is called what? Weight force, right? Yes. A downward force is called weight force. So weight force, W, equals to mass times acceleration due to gravity. So let us get the weight force. Weight force will be equals to 10, because now we have, 10 kilogram, which is the mass, and the acceleration due to gravity is what? 10 meter per second. So 10 times 10, that is what? 100. So the weight force is what? 100 Newton. So that means this box is exerting a weight force of what? 100 Newton on the box. Now, if you look at the question, the limiting frictional force is the force that have to be overcome, right? The maximum force that have to be overcome for this static object to be in motion. Now, do you know that when this box rests on this surface, the table also exerts another force called what? The normal force. And because the box is stationary, what happens? The normal force is the same as what? The weight force. So that means the normal force or the normal reaction is also the same thing as what? 100 Newton. Now, if you want to calculate the force, we know that frictional force is the product of what? Coefficient of friction and what? Normal reaction. Frictional force will be equals to, the coefficient of friction has been given as what? 0.2. So I'm going to have 0.2 multiplied by the normal reaction, 100 Newton. So frictional force is what? 20 Newton. So the correct option to that question is option B. Option B is correct. I hope you understand. That's it. If you encounter this kind of question in exam, first pay attention to the parameters. You understand? That you will not be given direct question in your exam. That's it. So you have to pay attention to the parameters, pay attention to the unit. You can see that the unit here is in 10 kilogram. If you use 10 kilogram directly, you're going to miss it. Okay? So let's proceed to the next question. Which of the following is a disadvantage of friction? Yes. Disadvantage of friction. Number one, okay, A, we have writing on paper. B, wear and tear of machine parts. You can see. C, walking on a road. D, stopping a car with brakes. A, C, and D. Option A, C, and D are advantages of friction. Option B is the only disadvantages of friction. Friction causes wear and tears, especially when there is no any method of reduction between the surface. The machine begins to tear. So the correct option to that question is option B. Let me erase this. I'm also coming with theory question though. These are just multiple choice questions. So I'm also coming with theory question. This is 18. Oh, okay, this is 18. Then we have 19. The correct question, the correct option for question 19 is option B. Option B is correct. Okay, for question 20, which will be our last question for tonight. Terminal velocity is reached when the weight of a falling object is balanced by A, the normal reaction, B, the upward viscous drag, C, the static friction, D, the velocity gradient. The correct option to the question is option B. Why? I told you if you when the force is balanced, what happens? The object stops moving, right? It stops accelerating. It stops falling. Are you getting it? So if it falls at a constant speed, that means the force acting on the object is balanced. If the object is falling at an higher speed, that is the speed is increasing, the force is not balanced. Now, when the force is balanced, it's force at a constant speed. So the correct option to that question is option B. The terminal velocity is reached when the weight of a falling object is balanced by the upward viscous grad. Now, listen to me. All these questions that I gave to you, they are just practice questions, okay? You can look for more questions and solve by yourself. Are you getting it? They are just practice questions. Now, I'm also coming with theory questions. These are just multiple choice questions. I'm coming with theory questions now, but before I drop that theory question, it depends on you. I have many questions on this. I have many questions, but it depends on you. All I ask you to do now is this. I want to see your reaction on the video. If you want me to drop the theoretical question as touching this concept, I want you to like the video. You understand? I want to click on the like button now. Are you getting it? And I want to drop comments. It is not important to give you what you don't need. Do you understand? I'm here to give you what you need. So if you didn't do that, I will assume that you don't need it. So I'm going to skip it and move to another topic. Okay? So that will be all for this class. If you have any question, don't hesitate to let me know. Okay? In the comment section. Also, do not forget, I have theoretical question, theory question as touching this. If you want it, react to the video by liking. Okay? See you in the next class.